Okay, we're going to talk about equations as relations today. This is going to be Unit 4-4. So you will have notes, video notes, and you will have work to do. So that will be due into us by the end of the week, both Miss McGuire and myself. Okay, so an equation that has two variables. An example would be y equals 3x plus 2. It has two variables. We have an x and we have a y. A solution of an equation with two variables is an ordered pair that results in a true statement when substituted into the equation. So I'm going to do 3 examples, and we're going to be looking for something different in each example. All right, so example 1, the equation is going to be y equals 2x plus 3. And I'm going to give you a replacement set. So these are the ordered pairs. -2, -1, 1, 3, 0, 4, and 3, 9. Now we want to know if any of these ordered pairs satisfies this equation. Is it a solution for each one of these ordered pairs? So we're going to substitute. So I'm going to repeat, always write down your equation. So the first one I'm going to substitute is -2, -1. So -1 equals 2 times -2 plus 3. -1 equals -4 plus 3. -1 equals -1. So this is true. So that ordered pair is going to be a solution to this equation. So we're going to do that for all 4 of these ordered pairs. So y equals 2x plus 3. Substitute again. 3 equals 2 times -1 plus 3. 3 equals -2 plus 3. 3 equals 1. So that is not a solution to this equation. So let's try y equals 2x plus 3 again. And we're going to say 4 is equal to 2 times 0 plus 3. 4 equals 3. That also is not a solution to this equation. And then the last one would be 3, 9. So y equals 2x plus 3. 9 equals 2 times 3 plus 3. 9 equals 6 plus 3. 9 equals 9. So that is. So those two that with the check marks, those two ordered pairs satisfies that equation. Okay, so now let's go on to example 2. Okay, now example 2 is if we give you the domain, can you find the solution set by finding the range using the domain? So this equation is b equals a plus 5. Now, just because we're not using x and y, you can use any set of variables that they put in there. Always remember that the letter that comes first in the alphabet would represent the x. X comes before y and it's the input. A would be the input and B would be the output. Now they give you a domain of -3, -1, 0, 2, and 4. So what I would do is make a table, and I would use A and B. And then for your ordered pair, do your ordered pair AB. So I would take -3. So I'll write one of them out. B equals A plus 5. B equals -3 plus 5. B equals 2. So if A was -3, B is 2, so the ordered pair is going to be -3, 2. b equals a plus 5, b equals negative 1 plus 5, b equals 4. So a would be negative 1, b would be 4, it would be negative 1, 4. I'm going to fill in the rest of the domains here, 0, 2, 4, and I'm just going to walk through them. I'm not going to write them all out. So a is 0, so 0 plus 5 is going to equal 5. That's going to be 0, 5. 2 plus 5 is 7, so that ordered pair would be 2, 7. And 4 plus 5 is 9, so that's going to be 4, 9. So those are going to be the solution set, and you would write them out as a solution set. So it would be negative 3, 2. It would be negative 1, 4. It would be 0, 5, 2, 7, and 4, 9. That would be the solution set for that equation. All right, now the last example, you have to change the order of the problem. So the equation is going to be 4x plus 2y is equal to 10. And the domain is going to be negative 1, 0, 2, 4. And you need to find the range. This is the domain. So you could go ahead and substitute in negative 1, 0, 2, 4 in for x and try to see if we could find the y. It takes a little bit extra time. So for this one here, I want to change the order of this equation so that we can actually substitute in for x and find the y really easily. So in order to do that, I'm going to rewrite it. I'm going to move the 4x to the other side of the equation. I want to isolate my y, so I have it like our first example was, y equals 2x plus 3. So I'm going to subtract 4x from both sides because I have to move it to the other side of the equation. And I'm going to get 2y is equal to 10 minus 4x, or plus a negative 4x. I'm going to divide everything by 2. And I'm going to get y is equal to 5 plus negative 2x. So that's going to be my equation. If you want, you can change the order. Y equals negative 2x plus 5. This way it makes it a lot easier when we substitute in our domain to get the range. So once again, I'm going to make a table. And I'm going to do my x, my y, and then my ordered pair. Okay, so my domain is going to be negative 1, 0, 2, and 4. Now, I could write it all out and substitute, but I think you guys are bright enough to understand that you can just substitute in your head. So I'm going to take negative 1 times negative 2, which gives me a positive 2, plus 5 is 7. So this is going to be negative 1, 7. Negative 2 times 0 is 0, plus 5 is 5, so that's 0, 5. And then negative 2 times 2 is going to be negative 4. Negative 4 plus 5 is 1. So that's going to be 2, 1. Then I'm going to take negative 2 times 4, which is negative 8. Negative 8 plus 5 is negative 3. And that would be 4, negative 3. So your solution set is going to be negative 1, 7, 0, 5, 2, 1, and 4, negative 3. And then in this particular case, they want you to graph it. And you guys all know how to make a graph. And these notes are also going to be in section 4.4.